Hello and welcome everybody to our first edition of Let's Talk Science in 2023. In 2033, the production will be completely wireless. That is our thesis today, and Mr. Jan Mertes will explain to you why he thinks so. The background is there is a trend towards customized products and batch size 1 production, but there are still quite a lot of challenges to overcome in making the transition to flexible production. 5G, the new mobile communication standard, will make this transition possible for most companies even in the near future. Mr. Mertes expects that the hardware for 5G manufacturing solutions will be on the market already in 2 or 3 years. So he's about to explain how you should prepare for this new technology to gain a competitive advantage of it. Mr. Mertes is a research associate at the Institute of Manufacturing Technology and Production Systems, FBK, at Technical University Kaiserslautern, and he specializes in the research of digital technologies in production systems. He's also a project manager in the 5G Kaiserslautern project, in which various 5G use cases are being investigated. I'm therefore very curious to hear what you will report about the state of research on 5G, Mr. Mertes, and what potential you see in 5G, also with regard to the control of machines. So it's my pleasure to hand over to you now.
Thank you very much. Yeah, hello also from my side. My name is Jan Mertes. I'm a research engineer at the Institute for Manufacturing Technology and Production Systems at RPTU Kaiserslautern-Landau. Yes, our name changed this year. We are not the TU Kaiserslautern anymore, even if it's standing down there. And I'd also welcome you to this session of Let's Talk Science. Today we talk about the potentials of 5G for manufacturing and what is interesting for you. To the agenda of my talk, I will give a brief motivational talk. Why is this topic relevant at all? Then we talk about 5G mobile communication standard in general. I will introduce you to the research project of 5G Kaiserslautern. Then I will talk about our research at our institute and about 5G in manufacturing. Some benefits and current limitations for manufacturing are outlined. And then I will give you a brief summary and outlook. To the motivational talk. Modern manufacturing systems want to connect the physical world with the digital world. So-called cyber-physical production systems consist of many different devices and machines, smartphones, CNC machines, robotic arms, that have to be interconnected with each other. But this, as you can see on this figure, also leads to a big problem, especially for existing manufacturing systems. The problem are heterogeneous industrial communication technologies. We have wireless technologies, for example, for smartphones, wired technologies, for example, for CNC machine tools. This also leads to a high individual setup effort and a lack of interoperability of different applications. But there is a potential solution, the 5G mobile communication standard. This 5G mobile communication standard is the next generation communication standard developed by 3GPP. The main performance characteristics you can see on the right side in this triangle are enhanced mobile broadband with 20 gigabit download rates and 10 gigabit upload rates, massive machine type communication, so many devices can be connected simultaneously in one radio head, and an ultra-reliable low-latency communication with latencies below 1 millisecond while maintaining a high quality of service and reliability. But as indicated in this triangle, this is not simultaneously achievable, and one has to optimize the network regarding one of those KPIs. Therefore, a specialty of 5G comes into play. The industry-oriented development and the possibility for private campus networks. As a company or university, you can license a defined frequency spectrum from Bundesnetzagentur to build up and operate your own private campus network. In this network, you can optimize different so-called network slices regarding your requirements for your use case. So basically, you can achieve with one 5G network, also in one radio head, those different key performance characteristics. Another important thing of 5G is that it's an ongoing standardization process, which means that it is compatible in the future with future communication standards, mobile communication standards. For your information, the 5G development happens in so-called releases, but not all functions are implemented since the first 5G release. The first 5G release is 3GPP release 15. For example, this ultra-reliable low-latency communication is implemented for release 16. Currently, release 17 has finished and work on release 18 has started. So to sum this up, 5G has the potential to enable different industrial use cases even simultaneously. But implementation, evaluation, and validation, especially for manufacturing, of the 5G potentials is still needed. And that's the reason why 5G Kaiserslautern, or the research project 5G Kaiserslautern, exists. It's a project with different institutes at RPTU, and the goal is the evaluation of the potentials of 5G for different sectors. For example, for agriculture, for smart cities, for intralogistics, and also for manufacturing. What did we do? We built up our own standalone 5G network with indoor and outdoor areas and one core at our data center. Important at this project, we want to use hardware that is currently available on the market, so it's very user and application oriented. We have different use cases. For example, we have autonomous guided vehicles at DFKI for logistics or intralogistics. We have autonomous transporters that drive around our campus, controlled via 5G. We have flexible AGVs with a robot arm. And we also have a 5G enabled machine tool control. And this is what we are talking about later, because this is the use case we are looking at our institute. But let's first talk about some 5G hardware so that you all have an imagination what one can use for 5G connectivity currently. First, there are so-called ball grid array chips. The advantage of those chips is that they are highly and directly integrated into the device, and they are very, very compact. But a very high engineering effort is needed. So basically, this is just suitable if you are producing many of 5G enabled products, for example, many sensors or 5G enabled mainboards. And that's also the reason why we in our project basically don't use them at all. What we are mainly using are so-called M2 modules. They are very simple to integrate into different processes, and basically you just need a USB or LAN interface at the device that should be 5G enabled. So you can see over there, I also have such a Raspberry Pi with such a M2 module. I hope you can see it on the camera. The problem is that a router board with an M2 interface is required, so also more space is needed, and it's potentially a little bit slower than those highly integrated BGA chips. But in general, it's very good for serial production, and it's very good for retrofitting of 5G capability in your process. Last but not least, we also have 5G routers, for example, from Siemens or Mikrotik. Advantages are that it's very simple to integrate into application, and there exist different designs for different use cases, for example, for industry use cases, for office use cases, or even for outdoor use cases. It's also very simple handling for operators, because basically you just have to plug in a LAN wire. Challenges are that they are not integrated into devices, and it's much more physical space required than with BGA chips or M2 modules. Okay, Then let's look at the research at our institute FBK and the 5G enabled machine tool control. On the right side you can see a milling machine tool that we built up ourselves that has been 5G enabled. What were the goals of this use case? First, we want to develop a machine tool with offloaded closed-loop motion control via 5G to an edge server. This is also a benchmark use case for ultra-reliable low-latency communication. So if this works, basically everything else will work too. Then we want to develop a 5G-capable digital twin of the machine tool for simulation, monitoring, and diagnosis purposes. And of course, we want to investigate the 5G characteristics on the shop floor and examine the operational limits of the current 5G network we are using. Brief introduction to the architecture of the system. The system is divided into a digital system, a communication system, and a real system. The digital system is completely offloaded to an edge server, and it consists of supporting instances and the digital twin itself. The supporting instance basically is a computer-aided manufacturing program that sends workpiece features and 3D model data to the digital twin. The digital twin then consists of a simulation based on Unity gaming engine and the CNC control unit, which is based on Linux CNC. The real system consists of a self-built 3-axis CNC milling machine, you saw it before, with step motors and encoders on site. And the communication system, as the heart of this setup, of course, consists of a 5G network and a 5G capable motion control board. The target positions are then sent to this So now we talk about current limitations, and unfortunately, or of course, there are some limitations. One limitation are the high initial investment costs for a 5G network. 5G private networks are starting at 100,000 euros and can go up to 7 figures, and it's dependent on the area you want to cover, the throughput you need, or the number of radio heads. But as a company, one has to see the ramp up of a 5G network as an investment into digitalization and infrastructure on a whole strategic enterprise level. So in the future, there will be synergetic effects, and 5G can be basis for a variety of industrial use cases. But at the moment, one has to say an individual assessment is needed for companies if such a ramp up of a 5G private network is good for you. Then another big problem is there's currently just release 15 hardware is available yet. And I told you before that ultra reliable low latency communication, what we basically need for our purpose, is part of release 16. So the complete offloading, including the PID control, is not possible yet. So at the moment, we need the instance of that on site. But as you saw in the video, and hopefully you heard, process simulation and monitoring via 5G is possible. Reading and writing of the signals and input and output status directly out of or into the CNC unit is possible. And now I want to show you some performance characteristics of our 5G network. This is just that you can get an understanding of the difference between wired and 5G communication. And this is just a measurement we did last week, so you can get the magnitude of the difference. It's also just exemplary because we did not do correct time sync between edge server and CNC unit. That's also the reason why we got latencies down there via the 5G network. It's around about 1 millisecond higher. So 5G in comparison to wired transmission looks way worse. The benchmark, wired benchmark, is down there, always below 1 millisecond. With 5G, we have 24 in max and around 2 millisecond minimum latencies. So we have a mean latency of 6.8 milliseconds, a jitter of 2.5 milliseconds, and a standard deviation of 3.6 milliseconds. So this is no hard real time and not deterministic. But for our use case, it's also not needed. So for monitoring manual control, this is sufficient. You can also see this line at 10 milliseconds. This is a self-set requirement to meet the characteristics of industrial-grade communication protocol, in this example Profinet, for this purpose. Usually for our machine tool, 15 milliseconds for manual control is sufficient. Then I also have some data weight measurements. They are tested with a Huawei P40 Pro, download upload rate 7 to 3, and it's an internal TCP test, and we have a download rate of 722 megabit per second and 233 megabit per second. To sum it up again, 5G has the potential for disruptive change of connectivity in manufacturing. It has a very good performance, but it's also a highly complex communication technology. So SMEs should already build up know-how in order to not lose touch of ongoing digitalization in manufacturing. But is the question from the announcement of this presentation answered? So will the manufacturing system be wireless in 10 years? We have to say it depends totally on the use case. For holistic interconnectivity, it's highly likely. On a machine tool level or below, it will depend on the exact use case. For high precision CNC machining with needed hard real time far below 1 millisecond, we are talking about 25 microseconds. 5G is not a solution, of course. But for automated guided vehicles, flexible manufacturing, and normal machine tool monitoring and control, it's already possible and will be implemented. So as a brief outlook, of course, we do further evaluation of challenges of 5G in manufacturing. For example, as an institute for manufacturing technology, we want to check the part quality when the machine tool control is offloaded, so when release 16 hardware is available. And for your information, companies can also come to us and test the 5G campus network also with their products. We want to update the 5G network to release 16 hardware. There's a data-driven extension of the 5G-enabled shop floor currently under development, where we utilize 5G-enabled sensors or sensing devices. And of course, we also have research efforts regarding future wireless communication. We are also part of the Open6G hub, so we already checked the new ongoing standardization process regarding 6G. And there we have high frequencies and the potential for hard real time. And basically that's the next step beyond 5G. There you can see the references if you are further interested. Hopefully you could hear me this time. And I thank again for your attention. And now, do you have any questions if we don't have lost everyone?
Thank you very much, Mr. Mertes, and sorry again for the technical problems. We heard you perfectly now, and I hope everybody is still on board. Anyway, I think we got a very good overview on 5G and how it will change production. However, as usual, everybody of you still has the opportunity to ask questions and discuss with Mr. Mertes. You can put your questions in the chat window. You see it on the right side of your display. Well, to give you some time for it, I would like to start with the first question. As you explained, companies need their own network for the transition to 5G supported production. So how can a company build up its own private network?
Yes, very good question. Thank you. So as a first step before building up a network, I would, as I said in the talk, evaluate which use cases are currently relevant, do a potential and benefit analysis for different use cases, and then check if a 5G private network is needed. If you say, yes, I need a 5G private network, then you can go to a network operator, basically Nokia or Ericsson in Europe, or you can consult a service provider, for example, Smart Mobile Labs. They are sitting in Munich. There exist not many service providers, but they exist. And then it's an individual process, and you talk with network operator and or service provider, and they help you in building up your individual 5G network. With the individual needed radio heads, I mean, it's a difference of you need indoor radio heads, so indoor 5G or outdoor 5G or both. So it's an individual process. Yes, another possibility, if you are SME and are at an industry park, there also exists the possibility to have one 5G network with different companies that are logically not connected to each other. So that's, for example, a possibility to save some money if you have some companies around you that also want to have a 5G network in your industry park. Are there further questions, or is the question answered?
Yes, the question is answered. Thank you very much. I would like to know if you personally in Kaiserslautern, you had some problems in operating your 5G network.
Yes, there were some problems, especially in the beginning. We had stability issues and it did not work very well. One has to say we had the first 5G standalone network from Nokia in Europe. So there was basically no knowledge about the technology. It was in the middle of 2020 when the operation started of our 5G network. At the moment, everything works, but unfortunately, we don't have many optimization possibilities due to this release 15 hardware. On the network side, we already have release 16 capabilities, but the connected devices, so basically the M2 modules I talked about, or the routers, are still based on release 15 hardware.
Mm-hmm. Okay. There is another question which came up meanwhile. What does the switch to 5G mean for employees? Is further training necessary?
It depends of which, first, thank you for the question, but it depends of which employee we are talking. It's a very, for the employee who is the machine operator, basically, there's in the first step not such a big change. But for the IT or the IT department of your company that wants to administrate the 5G network, they have to learn a lot about mobile communications. But there's also the possibility to let the service provider I talked about that can build up the private network also let them operate the private network. Then you basically have a 5G network as a service, and you just say, I need those performance characteristics. I pay you that amount of money. You have to look that it works. And then for the employees, basically everything is the same. Of course, in the future, when there will be many 5G networks that are deployed and are in operation, also the manufacturing itself will look not like it does today. So, I mean, we often talk about less jobs on the shop floor, but in my opinion, then these jobs are of course needed to deploy the 5G mobile communication network. So maybe there's a shift between knowledge in IT and communication knowledge and the machining tool knowledge. Did this answer the question?
I think so, yes, thank you. Another question, what is the status of 5G in other countries?
Basically, in the Western world, it's quite the same. We, as I said, in the 5G Kaiserslautern project, we just want to use hardware that is currently available on the market. So of course, there are already developer and experimental Release 16 modules, for example, from Qualcomm, but that's not what we wanted to use. We wanted to use what the SME currently also can buy on the market. I know that Huawei also has some Release 16 modules, but that's basically not my topic of research. That's just what I know at the moment. I think there are some experts also in 5G Kaiserslautern, basically the guys from the wireless communication department, that also can answer this question. So maybe a little bit better. So if you have a question regarding that, you can also consult them. Their contact is also in the handout.
Okay, thank you. Do you plan further use cases for manufacturing?
Yes, of course. Maybe you still see my slides?
Yes, we see it.
Okay, maybe I also talked about this data-driven extension. What we also did currently, we just added a smartphone for data acquisition, because such a smartphone, there are many sensors inside of it, also acceleration, vibration sensors. And one very good thing, it's out of the box 5G capable. So you have no issues with 5G capability and no issues with wires. And currently we are checking what can we sense or what information can we get with a smartphone that we just put into this process, in this machining process, and what analysis can we do with smartphone data. So we send the data via 5G directly to the edge server or to an edge server, and their analysis and visualization occurs. This is current topic of our research, and on the edge server runs some machine learning algorithms for predictive maintenance, but unfortunately at the moment I cannot give you more information about that. But this also will be published soon, so if you're interested, you will hear from that use case too in the future.
Okay. Thank you very much again. And as far as I can see, there are no more questions. So I think we got a very good overview of what can change 5G in production. Thank you again, Mr. Mertes, and good luck for your further work. And thank you also to the audience for your interest and questions. And as we said before, you will find a handout on the website of Let's Talk Science. And last information before you leave, our next issue of Let's Talk Science on February 22 will focus on vibration-assisted machining, a new technology which also is already on its way to industrial application. It makes serious production much more energy efficient, and I think in times of energy crisis, this is certainly a topic that concerns everyone. So we are looking forward to welcoming you back to Let's Talk Science in February, and sorry again for our technical problems. Until February then, take care and bye-bye.